All right, today we're talking about the fundamentals of probability. So let's start with a couple of real basic terms and then we'll jump in and look at what this all means. The blank are the most basic possible results of an observation or experiment. For example, if you toss two coins, one possible outcome is heads tails, another possible outcome is tails heads. This is what we define as an outcome. So in other words, in a probability experiment, we're going to roll dice. What's going to happen? What could happen? It could be one, could be a two, could be a three. So those events we refer to as outcomes. Speaking of which, an event consists of one or more outcomes that share a property of interest. For example, if we toss two coins and count the number of heads, the outcomes head tail and tail head both represent one head and one tail. Okay, so let's look at an illustration of this. Consider families of two children. List the possible outcomes for the birth order of boys and girls. And if we're only interested in the total number of boys in the families, what are the possible events? So I could have a boy first, and after the boy I could have another boy. I could have a boy and a girl. I could have a girl first and then a boy, and I could have a girl and a girl. Okay, now looking at this, what are the total events, or what are the types of events that can occur? I could have two boys, in which case there's one event for that. I could have one boy, in which case there are two events for that. There's the boy girl and the girl boy. And I could have zero boys. And there's only one event where that happens, and that's the event where I have two girls. All right, the probability event expressed as the P parentheses event is between 0 and 1. Okay, so for example, if the weatherman says that there's a 30% chance of rain. Okay, so when we talk about the probability of an event, we refer to it as some number between 0 and 1. So 0, for example, means that an event is impossible. And a probability of 1 means that that event is certain. Now, this is where I'm going to reference weathermen. Weathermen, I think, are an awesome job. I don't think there's a single job in this world where you could show up, make a prediction, be wrong every day, and still get paid lots of money to do it. Great job. So even if they say that we expect there to be a 100% chance of rain, that means that it will rain that day somewhere. Sort of the difference is how they get away with saying those sorts of numbers. And if there's a 0% chance of rain, that means it is impossible for it to rain today. Now, weather's kind of a strong event, but 0% chance of blizzard in the middle of July in Houston. Knock on wood. That would be something to see. Okay, so when we want to count the theoretical method for looking at equally likely outcomes, first thing we want to do is we want to count the total number of possible outcomes. So what could happen? And among the possible outcomes, we want to count the number of ways that the event of interest, which is the one where we actually want to measure, can occur. And then we want to determine the probability of that particular event. Probability, or probability of A, event A. So probability of event A is the number of ways that A can occur divided by the total number of outcome. Okay, so we're going to apply the theoretical method to find the probability of the following. Exactly one head when you toss two coins. Okay, so let's make a list of what could happen. If I toss two coins, I could get head head, could get head tail, could get tail head, or I could get tail tail. Okay, so there are how many outcomes? There are 4 outcomes, and I'm looking at the probability of one head occurring. So of these 4 outcomes, 2 of them show up in that list of 4, and we can reduce that, always reduce if possible. So the probability of one head occurring is 1/2. Okay, probability of getting a 3 when you roll a 6-sided dice. So probability of a 3. Okay, well, what could happen? I could have a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possible outcomes, and of which there's only one that's of interest to me, and that's that number 3. So there's 1 out of 6 possibilities. There are 52 playing cards in a standard deck. There are 4 suits known as hearts, spades, diamonds, and clubs. Each suit has cards for numbers 2 through 10, plus a jack, queen, king, and ace, for a total of 13 cards in each suit. Notice the hearts and diamonds are red, and the spades and clubs are black. Okay, so if you're not familiar with the deck of cards, me describing them to you might not be the best way to do it. So if you've got a friend that maybe has a deck of cards, maybe it's a little bit easier to kind of see these things. I find that there are students out there that have used cards their whole lives, and there's some that have never touched them. So anyways, but probability is a great chance to talk about cards and answer questions about them. So, the question we're trying to answer, if we draw one card at random from a standard deck, what is the probability that it is a spade? Okay, so probability for a spade. Okay, how many total cards out there? There are 52. And of the 52, how many of them are actually spades? Well, 4 suits, and there are 13 in each suit, so there are 13 out of the 52, and we actually can reduce that. That goes down to 1/4. So 1/4 of the cards are an actual spade. Okay, assuming an equal chance of having a boy or girl at birth, what's the probability of having 2 girls and 2 boys in a family of 4 children? So the tricky part is we have to map out all the possibilities just to figure out, because we have to figure out that denominator where we're listing out all the total outcomes. So we're just going to sit here and think of all the scenarios that could happen. I could have all 4 girls, in which case it's just all 4 girls in a row. I could have 3 girls and 1 boy, and the tricky part is where that boy shows up. So maybe I had him at the front, or maybe I had him the last kid. Maybe he was the 3rd oldest, maybe he was the 2nd, or maybe he was the 1st. So there's 4 possibilities there. I could have 2 girls and 2 boys. So maybe I have the girls first. Maybe I have a girl first, and then a boy, and then a girl, and then a boy. Maybe I have the girl, 2 boys, and then a girl. Maybe I have the boy, girl, or boy, boy, girl, girl, or boy, girl, girl, boy. Okay, so there are 6 possibilities for that. 1 girl and 3 boys. So 1 girl and 3 boys is kind of going to look a little similar to the 3 girls and 1 boy. Just with the letters reversed, so I could have the girl first. I could have the girl second. I could have the girl third. And I could have the girl at the end. And then the last scenario would be all 4 boys total. And so when I count up all these total combinations, I should get that there are 16 of them. So the probability of 2 girls and 2 boys, okay, there are 16 total, and then I just need to count up how many fit in that category, and that's this little category here, and there are 6 of those. So 6 out of 16, or 3/8, which works out as a decimal is like 0.357. So almost 36% of the time I would expect to have 2 girls and 2 boys.